So, hello everyone, we would like to talk about our journey to the Pown2own contest. Oops. Sorry. Just a mistake. So, for this contest we were 4 of us. So, Eloise Broca, Damien Cauquil, just here and present, Robin Davin, and me. We work mainly as a hardware and software reverser, and we will see, we will like the embedded devices, and it's why we participate to a Pown2own contest. So, just to remind those who may not be familiar with it, Pown2own is a worldwide contest that includes multiple targets as automotive, routers, domotic equipment, operating system, among others. The goal is to exploit these devices to gain root access in less than 5 minutes. While 5 minutes seems a lot of time in the export world, you will see that it's not actually so long for us. So you will see. To go deeper into the rules, for local devices, only one type of vulnerability was accepted, remote code execution. And for the routers category, there were 2 possible vectors, via the LAN side and the WAN side, with a higher cache price for the latter. And so the WAN, wide area network, is the side connected to the internet, which means that anyone around the world can access to it. In comparison to the LAN side, local area networks can only be accessed by device directly connected to the routers, and all devices who communicate with the routers through the LAN. So here you will see the router that we will attack. And this year, Netgear has introduced an interesting new category called Smash Up. The goal is to compromise a device from the routers category and then pivot to local devices. And for this category, the exploit must be executed within 10 minutes. So now let's focus on our organization to participate in the competition. The contest published the list of the targets around August, and we began to review them only on 22 September. And it took us around 1 month to choose the potential targets, the Netgear RX30 and the San Originas. As a part of our team, we only focus on the Netgear RX30, so we will only discuss on during this conference on Netgear RX30. So we began to working on the device on October 31st. Within a week, we found some vulnerabilities, although they were not eligible for the contest. For instance, we got multiple crash that implied DOS of the routers, but we were here only to get a root access. So, just to begin, we begin to get a root access with physical access. So it was not really difficult because we just need to type /bin/sh and you gain a root access. Wow, that was a change. The next week was pretty quiet, but the following week we discover a way to achieve remote code execution on the device. But you will see that was not actually works in our case, but never mind. We found 4 other ways to achieve a remote code execution. 3 for the WAN and 1 for the LAN. So we had 15 days to prepare a contest. I think we are large. It's cool. But before spoil the end, let's begin our strategy for this contest. So what do we want when we go to this type of contest? We are here for the glory. We are here for the money. Yes, maybe. But if we go there for the money, we would like to minimize the research time and maximize the gain. But if the gain is high, probably it's more difficult. And we will look how organize our research time to get the best way to gain money. So vulnerability research and strategy. When we look at the one side, in general, we only have few services exposed. In some cases, none of them were exposed. Typically, we can find a web-based administration interface, an SSH services, and some other services were unnecessarily exposed due to a filtering error. However, for our device, none of these were exposed. So another way to access to these devices it's for the pork knocking feature. So when you're connecting classic scan, there's nothing up here. But when you follow a strange instruction, magical services appear. The last thing we can play with is the outgoing traffic. Nowadays, most of the traffic is encrypted. So anything is possible unless if you found a vulnerability inside the encryption or if we can inject some malformed packets. However, it's possible to usurpate the identity of the DNS server. Not the DNS server, but the access server. So, on this example, the routers access to the DNS server to ask an address of the server you would like to contact. But if our DNS server answer before the real DNS server, the router will access to the wrong server. These little tricks should not work because the router normally has a list of certificates to verify the identity of the server, and that's called pinning. And however, in some cases, the verification is ignored. Let's talk about one of these cases. When you use, for instance, curl binary to retrieve a web page, curl will verify the identity of the server before accessing the data. But when you use the -k or minus ignore, insecure, you don't verify the certificate. For instance, when you have a self-signed certificate, you don't want to verify the certificate because you know that it not actually works. So we will focus on this vulnerability and we see how we can automate the research at the binary level. At Quarkstar, we have a tool called Pandora, and Pown2own is the first time we use this tool in a real-world scenario. To explain what these tools can do, let me outline the different features. So we have extraction, analysis, and diffing. With extraction, we can provide the tool with an entire firmware to extract the firmware file system and create a tree view of the extracted data. Sometimes the extraction goes wrong, and in this case, we just need to explain how we should extract the firmware, and for the further firmware, it will be extracted at the same manner. And that is really cool. After completing the extraction step, we can move on the analysis, and we can examine the file system by resolving symlink to dig deeper into the analysis of binary and assembly code. And finally, with diffing, we can identify change in instruction level and see if some binary was changed and where. So this tool we can request an analysis of the firmware, examine its file system, analyze its code at deeper level, and identify change and difference. So let's take an example. If we take our case for our firmware, let's say a certificate pinning for outgoing 20, we can try to identify it. For instance, we can look for all instances of libcurl, but don't check the certificate of the URL. That's the equivalent of insecure or -k. So first, we extract the firmware, list of all binaries that use libcurl library, and then analyze all of the curl easy setup, and verify if this call set verify peer or verify host to 0. It's the equivalent to insecure or -k. And then just list all functions of all binaries that have a vulnerable call. By following this step, we can identify an instance of certificate pinning issue in this firmware. So now we'll target in LAN.
Yes. Thank you. So, when it comes to attacking the LAN side of the router, one thing we don't want to find is a denial of service attack, because this kind of bug, yeah, it's not very useful when you want to achieve remote code execution. But in fact, it gives you a good idea of the security of the router and mostly the security aspect of the code the firmware uses. So basically, you can find some local service crash. So you just crash a specific service through buffer overflow, maybe, or sometimes we don't know exactly why the system is the service crashes, but yeah, that's it. That's a simple bug. It could be useful to stop a given service, for instance. Also, we can look for a system crash by injecting some specific network packet, for instance. And in this way, you may kill the device and you need to reboot the device to get access. So again, this is not really useful when you're trying to achieve remote code execution. And last but not least, there is also a system resources exhaustion scenario you can trigger doing this. If you manage to hit too much RAM or busy the CPU enough to get the system stuck at some point. Well, when we were looking at the code of this firmware, we found some specific file, specific CGI file that handles file upload on the web interface. So this one was obviously on the LAN side, and it was unauthenticated. So it's anybody can just trigger this piece of code by uploading a file. And if you have a look at this decompiled C code, there is something wrong because this CGI stores the uploaded data into one file, which is called, depending on some conditions, /tmp/upload file or /tmp/multipart file, depending on the fact that the file is multipart encoded or not. But in fact, there is a for loop, and this firmware will write into this file whatever you send in the body of the request. So if you send a lot of data ends up in this file. And normally, most of you must know, but the /tmp /file system is hosted in RAM. So basically, if you upload a 1 gigabyte file through the LAN side, the system is totally stuck. So this was some interesting finding, but yeah, this is not really useful to achieve remote code execution. But in fact, this is something funny because it gives you an idea about the security skills of the developers of this firmware. So we got a temporary file that may eat a lot of RAM and unauthenticated upload. So unauthenticated denial of service vulnerability. And then we had a look at another part of the web server, and we found a way to bypass the user authentication required to access the administration panel. So basically, you have to log into the system with the admin username, or maybe it can be changed. Don't remember if it can be changed. Anyway, there is this user authentication panel, and you have to log in. And of course, there is a password wizard feature available because we usually lose passwords, so why not? And this password wizard feature requires the user to enter a secret question, the answer to the secret question. And what happens if you don't provide the answer in the JSON data? Well, in fact, it's just with the password. So the answer to the secret question is not very useful. So yeah, we had a way to get access to this administration panel. And yeah, there are more vulnerabilities to come. We also had a look at the firmware signature mechanism, and there are some parts redacted here because we don't want other people to break into this stuff, but yeah, we know you will do. Anyway, so this firmware signature system, well, usually we face a lot of different mechanisms, and one of the most secure is to use RSA or public key encryption just to be sure that nobody can break it. Normally. And in this case, they used SHA-256 hash algorithm with some secret values. Well, once you get the firmware, the secret values are not secret anymore. So we got these values, and we found a way to unpack a firmware totally to get all the root file system, the kernels, and so on, and to repack it with a correct, valid, and correct signature and valid signature. So using this, we could exploit a specific, or not exploit, we could use or abuse a specific mechanism, which is the firmware update feature available in the administration panel to install a new firmware. So, to summarize, we got an authenticated firmware upload through the auth bypass. We can use this unauthenticated firmware upload to break the device if we just install a wrong firmware or some code that just kills the device. We can also deploy a backdoor to access remotely the device. Or why not? If you want, you can install OpenWRT if you want to own the device and use it without the Netgear firmware, which is, well, vulnerable. So, it was all good unless we noticed we were not working on the latest version of the firmware. Of course, you know, when you are doing this, you are in a rush and just focus on the firmware files and so on. And, have you seen that Netgear released a specific update? Oh, no? Well, it was, yeah, we were a little pissed because of this. And some vulnerabilities we previously found were corrected, were fixed by this new firmware, this new version of the firmware. So we had to find other ways to achieve remote code execution.
So we look on the SOAP server. It's like a proxy server, but was not normally used by a user. It's just in internal services, but it was exposed on the 0.0.0, so anyone can access on the LAN. And we see a scanf function that was dangerous. And something interesting, it's not like the percentage as we probably know. It's like a percentage and a bracket, and after just avoid some character. And so if we it ended when you put a space or if you have an end of a string. So if we abuse of this this characteristic, we can just write a buffer overflow, and so we can have a buffer overflow here. But find this vulnerability is easy, but exploit it is more difficult. And we have here there are some update of Netgear, so we just wait to have the last update and see when we exploit it, because if we exploit the binary and you found your gadget and something like that, and just they recompile the binary, but the function is always vulnerable, your gadget was probably not be the same, and so you need to research. So we want to economize our research time, so we just put aside, and now we just look what the result of the automatization look like. So, if we take a closer look at the result of our automatic research, on the one side, we have found an interesting binary called pufwCFU, and that doesn't verify the certificate of a request host. So, easy. If you want to exploit this vulnerability, all we need is to use a DNS mask and provide the host we want to spoof, and pufwCFU asks for the URL that can be used to update the routers. However, we now need to determine which binary use pufwCFU, and we identify two binary that call pufwUpgrade and pufwUpdate. So, if we look pufwUpdate, it call effectively pufwCFU, and then call a function that call download file twice. So, just look a little bit at this function. This function verify the URI begin with HTTPS. Oh, so it's cool. And call curl again with the -- insecure. So if the URI begin with HTTP, so every time this function is called, and we can control the data received, we can just put HTTP and not HTTPS, and that's all. It's don't verify the certificate or something like that. It's okay. So, now if we try to imitate the behavior of a real server, we see that any protection prevents us from replacing the actual binary and download. And we only need to recompute the hash of the binary, and that's it. So, if we summarize the behavior of the binary, we just request get file info.txt, and that contains the hash, the size, and the name of the file. So we just rewrite this file, and we create our RIE binary, and that's it. We can check and run the binary, and so we got a remote execution. So we got the first one RCE. But if you look deeper inside the function download file, we have a number of things really interesting. But we provide the URL as the second argument, like in the SNPrintf. You can see that all the command is directly passed as a shell command. So what's wrong here? I think we can just do something like that. So we just put inside the URL semicolon and just our command to execute. And here we just recreate the a.csh file and execute it. It's simple. Now we can look at the other binary, pufwUpgrade, and it's slightly different from pure update. It's launched at during the early boot. But it's not like the call the remote server. It just schedule when it would like to execute the binary. So we don't know exactly when it will be executed. It's a random value. But the router don't have real-time clock, and we can just spoof the value. Even if it's random, you can perhaps try a candidate and see if you can execute at the correct time. And then pufwUpgrade works slightly different from pure update, like I said before. It's not only a simple binary; it's the whole firmware. The whole firmware. It's really important. So we can just replace all the firmware. And we see before also how to make a firmware, so it's great. We can just upgrade via v1, but we can something to add. pufwUpgrade don't check the signature, so we have to do some work to just reverse the signature, but we don't need to do that. We just need to put a 0 at this signature, and it's okay. It's validate. The problem with this vulnerability, it takes around 4 minutes and 20 seconds to be executed. And if you correctly remember, I say we have 5 minutes to be execute our vulnerability. So it's really short, and we need to be stressed when we want to execute this vulnerability. And the spoof time, the time we spoof, the time we spoof with the NTP is not be sure that it's the correct one. So we put aside this vulnerability because it's too much random. So just check, and then you have your malicious firmware. So we have 4 RCU on the device, which seems fine, but everything goes wrong. Netgear, publish, and hotfix. Just 1 day before the contest. And 3 of our vulnerability was just wipe. The injection command just was removed by an execvo, so we cannot do any more some injection. And pure update don't use anymore PUCFU. They just hardcoded the URL. So we cannot do just update this binary. And we just only got the LAN RCU and the WAN RCU. But the LAN, as I said before, it takes more time, and you have just 1 day to just exploit it. So we give up this vulnerability, and we focus on the random vulnerability. So LAN or WAN. Plan B.
Okay, I'm going to describe the way we took this decision to still participate in the contest. So, we had to elaborate a plan B as just a backup option. So, how to do this? Remember this over-the-air firmware check using the pufwUpgrade. So, this command is installed as a scheduled task during the boot, and this is a cron tab, set up by the system, and the values used to determine the minutes and the hours at which the system will be launched are chosen in a way it seemed random at the time we looked at this code. But if we have a better look at the code, there is something interesting. Because the machine, this router, has no NTP at boot time. So basically, the date and time set up by the system when it boots is just the compile time of the kernel. And if you have a look, it creates a seed using the time function in C, using a null parameter, which is basically how to get the timestamp from the system, on a 32-bit integer. And then it uses the srun seed initialization function, which is not very secure. So basically, we got here some predictable PRNG used on the system, and since we know exactly the timestamp generated by the date and time at which the system boots, yeah, maybe there is something to do. So there is no crypto-ONG. So exploiting this feature is, it was not really easy because we didn't know at this time when exactly this pufwUpgrade scheduled task was installed during boot. So it may be during the early boot, maybe 2 minutes after the first time the system boots. So we didn't know. So we had to check, and the only way we had to do this was to compute all the possible values we can get from this random generator, starting from the timestamp we got at extracting from the kernel compilation time. So we got this, we generated a huge file with all the possible values, and we started booting up our router. And since we had access to the root file system through the serial port, using this shell trick, we were able to extract a lot of possible values after a lot of reboots. So it took some time to get these values, and we had a very small set, like 10 possible values observed during these boots, and we compared these values from the one we got in this huge file, and we found a very small timescale where these values appeared in our file. So it was pretty obvious that the time spent by the system before starting this pufwUpgrade command, the scheduled task, took between 87 seconds and 96 seconds starting from boot. In the meantime, since Netgear published a hotfix, a lot of teams just decided not to compete, and we don't know exactly, but because some colleagues talked with these guys, but the guys from Star Labs decided to publish a blog post before the contest with all vulnerabilities they found. So yeah, it was very particular, but in this specific blog post they published, they gave some values they observed in this same cron tab file, and we had the confirmation that the 59 and 3 were in the timescale we were looking at. So it was just a confirmation that this track may be the one to get remote code execution. During our attempts, our tests, from our side, we got a lot of specific pair of values, which was 0 and 3, so 0 minutes and 3 hours in half hour twice. So it was a pretty interesting value. That means if you want to participate at Pown2own, you have 3 attempts of 5 minutes each. So maybe if you're lucky and you try again and again 3 times, maybe it will work on the device. Yeah, for 50% chance is not that much. So we need to weaponize this. We needed to figure out a reliable way to exploit this and to get more than 50% chance of success to exploit this bug. So we need to reliably guess these values. We know exactly how to change the router's date and time since we know how to spoof MTP. So it was not a very big deal here to get the correct date and time, or mostly the time here because the date doesn't matter. The idea was to install a rogue firmware. Like Benoit said, it takes around 4.5 minutes to get installed on the system and rebooted, fully rebooted. So the time is very short for using this, but if we manage to do this, we can implement some LED show and make the LEDs blink, and then we celebrate, we got the money, and success. So we decided to create an oracle, something that monitors some metrics, some events from the router in order to deduce the values generated by this random number generator. And we started looking at some information we could get from the router at boot time. And one of these information was the DHCP request the system sent sometime after boot. And we made the hypothesis that the time between the DHCP request and the time at which the pufwUpgrade-s option, which is the command that set up the schedule task for the firmware upgrade, this time the T quit time was constant. So this is just something we guessed, we hopefully, and we started measuring this T and T quit times. These times are supposed to be constant, and we did a lot of tests. We created this oracle and we compared the output of the oracle with the output of the files, which were the truth, and we did a lot of tests, and in fact, the success rate of this method was just about 30% chance of success. So, it was a pretty good idea. Sounded like clever, but no, that doesn't work. So anyway, during all these tests, we noticed that the pair of 0 and 3 was very common, and we got it a lot of time. So in more tests we made, we got 70% chances of success. So it was pretty good, and these values seem to be quite stable when we did this test. So why not? 70% of chances. Yeah, that's pretty good. Let's go to Pown2own. We have a chance, but still we have a 70% chance of success. We may fail. But anyway, let's give it a shot. We are going to test it. So we developed a specific exploit. We took a lot of efforts to create a very reliable exploit. So here you have the target, the RAX30 router from Netgear. And remember, when we exploit this, the firmware takes about 4.5 minutes to be installed and fully rebooted. So we needed to be quick. We needed to be fast during the exploitation. So we maximized our chances of success, and we finally got the LED show on the router. So it was cool. We had something working, we had a working exploit. So let's go to.
Yes.
You messed up with my clicker.
Yes.
Anyway, so let's go to Pown2own. We got an emergency meeting, just before, the day before the attempts, because,
at the early morning, and, everyone was just, tired.
Because, the order of passage is random. You don't, choose when you are going to try your attacks. We all agree we are going to use the 0 and 3 values. Yes, and we are
Yes, absolutely.
Yeah.
We didn't change.
Okay, so we stick with 0.3. This is the best option we have. So we attempted our first exploitation of this router, and this first attempt failed. Well, it was a bit stressful during this attempt. So just to be more precise, there are 2 of us who flew to Toronto to be, near the devices, just to be sure that everything is okay, that nothing goes wrong with the hardware, and Benoit and I were remotely connected, and we had one of our colleagues just streaming the attempts. So yeah, it's a bit more stressful to be to be remote and not being able to do anything to make it more easy for success. So yeah, we had also the whole team behind us. Yeah, with a lot of hope. Yeah, go Entropy, go! Second attempt failed too, so yeah, it was time to, before attempting the third time, just to have a little meeting and...
Wait. What did we do?
Yeah, we modified our predictive value, We decided to change these 0 and 3 values to something else because our exploitation included some metric, some monitoring, and we were monitoring the boot time of the router. And the 2 previous attempts, we got different values than the one we got when we tested it on our router. So we decided that maybe this is not exactly the same hardware or exactly the same context during the exploitation, and we decided to change this value because why not? And in fact, the third attempt failed too. So we had 3 shots failed. This is, no luck. But the saddest part of it is that during the last attempt, the values we got from our script were exactly the one we got during our exploitation attempts at home. So yeah, a bit disappointing here, but anyway. So just to conclude this talk, I don't know how much time we got.
It's okay, we have time.
Fine. So there are some takeaways here for you guys if you want to attempt pawning stuff at Pown2own. The first one is that you should not focus on trivial vulnerabilities, but more on non-trivial vulnerabilities, because other teams will easily find these vulnerabilities. And if you stick to what is not searched or looked at by other teams or the mainstream teams, this is your best chance to get something unique and something that won't be patched by Netgear a day before the contest.
And moreover, if a team was dropped before you, they will use this vulnerability, and so we will be just only on collision and not the full.
Yes, and to get the bounty, you need to be the first team to exploit this vulnerability. So if you are not lucky, like we were at this time, because we were
the last day, yes, it's not the best draw.
Anyway, so yeah, just focus on non-trivial vulnerabilities and you will maximize your chance of success. Also, find as much exploit path as possible, because if you get just one path and it got blocked by an update or anything, then you're doomed.
And yes, follow the same methodology. So if you have you just to take research time to see different path of vulnerability you can try. It's the best way, because you just can multiply the same methodology on multiple target. And so don't focus on one single target. Yes, it's better. So then, I will just encourage you to just participate, even remotely, because, you can just, provide the script to execute your exploit, and, it could be works. But in hardware, it's slightly difficult. Like you see, there are a lot of parameters that could not work. So we prefer to participate in present. But if you have not the money or not the time to go remote, to go on site, just go remotely and it works. And then remember that failure is always an option, like us. So, do you have any question on this talk? And if you have want to have more details on our research, you can go to the blog post we have just published this morning. So, thank you.
Thank you. Q&A session now. Is there any question? Yeah, also in the front.
Okay.
Thank you very much for your talk. First, I don't think you're a failure or that you failed, how you said. And one thing that came from my professional paranoia, it was that since this is a competition and there are other people involved, do you think someone informed the manufacturer about certain vulnerabilities that were more easily to find so they would attack indirectly other competitors?
Yeah, it could be a strategy. We have no proof that other teams did this,
Of course,
but it's a possibility, and it could be useful if you are quite sure that you have something unique, and you can just drop all of the other teams by just releasing the trivial vulnerabilities you found to the vendor, hoping that it will publish an hotfix or an upgrade some days before the contest starts.
Exactly, because those patches seemed very specific, in my opinion. Maybe they were not.
And for instance, Netgear have a bug bounty program, so it probably just you can provide a lot of vulnerabilities just before by the bug bounty program, and then participate to the DI contest, and you have a lot of money, so it could be works. Yes.
The Netgear's bug bounty program rewards were not as attractive as the Pown2own rewards for the same vulnerabilities, I guess. So it was but it's a possibility. We don't know.
Thank you.
Any other question?
Hey, thank you for the great talk. So, what was the potential cash prize, and did they offer you anything for the failure? Because as far as I know, they sometimes offer some money anyway.
If you manage to get a remote code execution on the router, from the one side it was 20k.
Yes.
And from the line side it was
the half, so it's 10k.
And can you gain both of those prizes?
Sorry?
Can you gain both of those prizes?
You can gain both. You have to register for both. If you register for one attempt for the one side, and you can also register one for the LAN side, and you can gain both. And if you can attempt also maybe 2 or 3 vulnerabilities on the line side. If they are unique, you get 3 times 10k.
And did they offer you anything eventually?
They offered something which was lower.
You didn't accept. And did you accept, or?
Yeah, we accepted mostly to cover our costs, because we sent 2 people in Toronto. But in fact, this was not exactly the same amount that you can gain if you manage to get remote code execution during the contest. But yeah, we reported all of these. Startups published a blog post with most of the vulnerabilities also we found. We may have found some extra vulnerabilities, but we are not sure that the startups too did not publish all they got from this research, so we don't know.
Yes, and we are currently in discussion with Netgear for some vulnerabilities. So
yeah, and some vulnerabilities have been reported, but not published yet.
Yes.
So yeah, it was a great experience from our side, because we learned a lot, and from the strategy point of view, and also the technical details from technical point of view, because it was quite interesting to see that such a router had so much vulnerabilities and so much flaws. But in fact, the strategy was something we did not consider at this time when we started the research on this device. But for next Pown2own participation, this will we will take care of this a bit more than we did last time.
Thank you.
Any other question?
Hi, thanks to. Since you failed, I'm sorry, did ZDI...
Oh, that's true.
Did ZDI still do the disclosure process for you and with you, or how did that look like in this case?
We got in contact with ZDI, and yes, they did the intermediary between us and Netgear.
So I think we have time for one more question here, and eventually a second one. We'll see.
Really nice talk. Thank you very much. Have you because you said that the upgrade time took like 4.5 minutes and you had to be really quick. Did you consider slimming down the firmware so it boots faster and stuff? Like, because you do not need to ship all the binaries. All you need is to get the light show.
Yes, it's why we just modify a little bit the firmware to be at the early boot and not necessarily to just have a full boot. But it takes 4 minutes and a half with this technique. But with more, it's like more 5 minutes.
The size of firmware doesn't, it doesn't matter a lot because the time spent, the 4 minutes and a half is it's just not 4 minutes to upload the firmware and 30 seconds to reboot. It's mostly the reboot time. So you have to wait for all the services to come up again. And this is a quite long process, before this, binary is called. So yeah, we could have developed a specific kernel in order to drive the LEDs just a shorter time, but it was, not that easy to drive GPIOs without any documentation on this device. So we would have reversed the hardware part and so on. So since we were quite in a hurry during the switches, like the timeline mentioned in the slides, we decided to just go to the simplest solution at this time. And since it fit in this 5 minutes slot. We considered that it was doable to exploit.
And just to add more precision, when you modify a little bit this firmware, when they begin to boot, we just wait 30 seconds to have a LED show.
Okay, and the second question quickly, because before organizer take the microphone, because you said you could isolate the router from NTP to break crypto.
Yeah.
Have you considered using that as a leverage to use HTTPS and break the cryptographic communication there instead of no verify only?
I don't know.
I think it's a little bit more complicated, and you probably allow a buzzword like IA, but perhaps, but I don't know.
No, I mostly breaking crypto with control of this date and time. There was another question we had at this time, if it was possible to modify the date and time many times during the attempts, so we could implement some kind of brute force for the values. But in fact, the router only makes one NTP request, and that's it. It was not possible to force the router to change its time multiple times, so it wasn't possible. But yes, maybe a crypto attack may work, but we didn't have time to figure it out.
Yeah, sure. Thank you.
Well, thank you very much. I think it's time to close this talk. Thank you for this great talk, actually.